The phase diagram represents the different phases, solid, liquid, and gas. It is a diagram composed of equilibrium curves between different parts of the same substance. Key characteristics of the graph include the triple point, the critical point, the y-axis is pressure, and the x-axis temperature. A line represents when two phases can occur at the same time, and regions represent a single phase. The solid/liquid line represents melting and freezing, the liquid line and gas line represent boiling and condensing, and finally the gas line and solid line represent sublimation. The triple point is equilibrium between solid, liquid, and gas, as you can see on the diagram below. The critical point is when liquid and gas are equal in densities, and you cannot tell if it is a liquid or a gas. This is the starting point of the supercritical area, which is the region to the right of the critical point. The supercritical area is to the right of the critical point, when the liquid and gas have the same density, meaning you cannot tell the difference. Phase diagrams can look different for each substance. For example, water is different than other substances. The solid density is less than the density of the liquid of water. That means that the phase diagrams for water changes. The line between the solid and liquid is slanted the other way for water. This means it can change from gas, solid to liquid at the same temperature. Here are some examples. The answer to question A is the triple point. The triple point is between solid, liquid, and gas, and the answer to B is the critical point. The critical point is at the far right on the line between liquid and gas. The answer to question C is solid. Solid is on the far left of most phase diagrams. And region 3, the answer to D, is gas. Gas is on the bottom right. The answer to example 2 is gas. If you use the diagram, you can find the pressure at 1, follow it over to find the temperature at 150, match those 2 points up, and you'll find yourself in gas.
Created using Powtoon.